Thank you for coming in and joining us. Happy Friday. It's hot today. Okay, so let's go ahead and get situated. I wanted to do some Code Wars first, of course. Always healthy to go ahead and do some Code Wars. So we're gonna do some 8. Okay, so I'm gonna do ones. I love doing Code Wars because I love being able to challenge myself on code I've never seen before, and I want to go ahead and see what I can determine from all of these information that I get. I might play. I was gonna play some music, but it's okay. We'll be okay here. Okay, so let's go ahead and get started. So Americans are odd people. In their buildings, the first floor is actually the ground floor. There's no 13th floor. Okay. So you're gonna write a function that, given a floor in the American system, returns a floor in the European system. So first floor being replaced by the ground floor, and the 13th floor is removed. So in case of above 13, they move down by 2 because there are 2 omitted numbers before them. Okay, key information to learn from here. But let's go ahead and do this. So we're gonna, so let's talk about our inputs, of course. So we're gonna go ahead and receive an integer. And it seems like stay the same as the universal level. Okay, so it seems like they'll always be positive integers. And then we're gonna return. So we're going to receive an integer that's positive. And we're always going to return the floor. Return an integer that represents the floor. That's horrible writing. That represents the floor in the European system. So, for example, if I have the first floor, it's actually ground 0. So it would be 0. But if I'm on the second floor, it will actually be the second floor, I would anticipate. So it's because the only 2 numbers, but if I'm on the 14th floor, I'm actually on the 12th floor because everything, example. So because it seems that here, there are 2 floors that are omitted. Floors that are omitted is the first floor and 13th floor. So we know that if so the way I would write this is that we know that so we know that the floors that are omitted is first in the 13th floor. So anything less than 13 minus, anything less than 13, we're gonna do floor minus 1. So if, say for instance, we are on the 6th floor, then we're gonna do minus 1, so technically we're on the 5th floor. Because 0 minus 0, so 0 equals 0, 1 equals 0, anything greater than 1, anything less than 13, and greater than 0. Else, if anything is greater than 13, we have to take that. If the n is greater than 13, take the total of n minus 2. So our room is equal to, so in here, our edge case, if n is equal to 0, we're just going to return 0. Otherwise, we're going to say that if n is greater than 1 and n is less than 13th, there we're going to return n minus 1. If elif, I'm going to do else if n is greater than 13, we're going to return n minus 2. So this should cover the case. So let's walk through the situation here. So if I have the n is equal to 8, I would expect n, since the first floor is removed, this will return back 7th. So if n is equal to 0, which isn't the case, so we're just going to skip this whole block of code together. Now we're going to step into this block of code right here, because n is greater than 1 and n is greater than or equal. N is greater than or equal to 1 and n is less than 13, which is the case here. So 8 falls in between this. We're going to turn n minus 1 and it will return back to 7. So this should be the case. So let's go ahead and try it. Yes. I'm just trying to think, like, can I write this in a ternary expression? Sometimes it's all, like, sometimes you could simplify the code, but sometimes it's all about, wait, hold on a second. So yes, as I was saying before, sometimes it's about, I was thinking, could I simplify this with like a ternary option? I think I definitely could. But it's okay. I'm gonna go ahead and leave it like this due to the fact that its readability is a little bit better. I can follow along with what's happening in the code. So I'm gonna leave it as is. Feel free to let me know what your thoughts are. Our time is definitely, I think it's gonna be constant, and our space-wise is constant as well. I'm gonna say constant because we're only looking for a number to return back. So we're not using up any space and memory, and then time-wise, we know that we are only getting an n. So like just one single number. And we don't need to iterate through every single digit up to that n amount. So we're just going straight to that n amount. So I'm gonna say O of 1. Please feel free to let me know if you think otherwise, but I'm gonna go with this. Okay, let's see what else they have to say. Okay. 9 should return, basement floor, if n is less than 2, we're just going to return 0. Well, actually, less than or equal to 0, we're just going to return 0. Wait a second. I was like, why is that so strange? Okay, that's my fault for not reading it right. So basement negatives stay the same as universal level. But, okay, so if n is equal to 0, we know automatically we're just going to return 0. That's my fault not looking at the last sentence right here. But if n, okay. What it is, okay, so if n is less than 0, then we're just going to return n. There are no, yes. Okay, we did it. Okay, because When I was looking at the results, such say for instance 389, when I was looking at it, it was asking for it to return negative 389. And the reason why I just decided to go ahead and say return n is because it was returning back negative 389, and there are no numbers that have to be taken away from it. So let's go ahead and submit. I like this one more because I love how simplified it is. Because if you're going to say that if anything is, I have like 4 if statements. In this one, you can shorten it to 3. Yeah, I was thinking we could have done a ternary condition. So return n if n is less than 1, else n minus 1. Okay, that was a good one to go through. Let's go ahead and do another one. Oh, okay, let's see. Okay, so count the number of divisors of positive integer n. So it can go up to positive, but fixed test can go higher. So for 4 we have 3 divisor. Okay, so basically what it is saying, no, you can only return a number the count of. Okay, so we're gonna receive an integer of the I wanted to make sure I say the right technical word for it. Divisor, dividend, the total, like the quotient total. But I want to make sure, because essentially, so we're going to receive an integer, which it represents the total, and then we're going to return, what we're going to do is we're going to return the count of how many numbers, essentially how many numbers can divide into this integer, how many numbers can divide into this integer, what's the word? How many, because technically all numbers can divide into each number, but then we want clean numbers. We want to make sure the numbers are clean. So we want to make sure, return the count of how many numbers can divide into this number, whole numbers. So because we don't want like 0.34 or 0.33, because technically you could divide all numbers by each other, but some of them you'll get like decimals back. So in my mind, I'm thinking I'm going to use a modulo, which is this. So say for instance, if I have an example of 3, I expect to see 2, because that would give me 1 and 3. Because 3 is a prime number, and you think about it, if 3 divided by 1, you get 3. 3 divided by 1, you get 3. But otherwise than that's about it. Because 2 can't really go into 3. And then 3 can go into 3 one time, but 1's already being counted for already. So you can disregard that piece. So the way I think about this, and if there's a pattern, if you look at it too, is that I would iterate up, I would initialize, let's go ahead and initialize a count to 0. And I would iterate up to n. Because you can see that all of the numbers right here are stopping at the total number. So that's something that I definitely would pay attention to. Hi, hello Ghost Magic. Thank you for coming to hang out. Feel free to chime in and help out too. So the more the better. But yeah, so this is a pattern based off of, please note I haven't done these algorithms before, but I'm just like looking at examples and trying to pick out like patterns that I see. So yeah, so I can see that this is 12, this is 30. They all go up to that in total. So that's what I currently see right now. Hi! Yes, you can, Solaris. Hi! Sorry, was I stopping you? Is there something on the chat that won't let you? Did I not? Feel free to let me know. hopefully I didn't do anything. So, okay, so we're gonna do that. Okay, so we're gonna iterate up to that n amount. So we're gonna check the modulo. Oh my goodness, you have been? Thank you for hanging out and being along for the ride for like a month. I appreciate it. I appreciate your time here. So we're gonna iterate up to n amount. And then the way that I think about it right now, which isn't the best, is to use every single number, iterate up to n, and check if each num mod the total is equal to 0. And meaning that there are no remainders, there's no left. No! Oh my god, I'm so sad. Okay, I need to go fix that. Thank you for letting me know. I hope I'm saying your username right. Solaris. I did not know I had that. So thank you for letting me know. Yeah, I'll go back and fix it. Because, you know, I really want anybody and everybody to go ahead and hang out. So I'm so sad that happened. I did not know that was the case. So, yeah. Well, yeah, that's true. That's true. Oh my goodness. I have to go back and check it out. So, yeah. Yeah, I love to know like Ghost Magic and Solaris. Like, what do you guys like? What languages are you guys currently learning? What's up with you guys? Is everything going? Are you guys learning algorithms too? And how's that coming along? So, yeah. So we're gonna check if each number total is equal to 0. The reason why I'm gonna check to see if it's equal to 0, because if we know that if the number is equal to 0, it's gonna be a clean, even, whole number. As you can see, 1 and 2, or sorry, 4 divided by 1 goes into 4, a whole number. Ah, I see. Counting the number of divisors can be done in O square root. I'll let you get there. The way I think about it right now is doing O of n, because I'm going to check. You got me thinking. Okay, so my mind. Okay, wait. So this time it definitely is going to be O of n. So I'm going to check each individual number leading up to that n number. And you're right, because definitely I can more optimized solution can be done in O of square root of n. Because if you do think about it, because technically all of these numbers are the square root. Is it? Let me think about this. Am I going to say that right? Because if I think about the square root of 12, technically, if we're going to say that if the time complexity is going to be O of square root of n, if you're going to say that it's going to be O of the square root, then it has to be like 81. Like a nice, clean, even square root number like that. Yes, I was going to say the perfect square. Like, yeah, like an 81 or 27. 3? Yeah, 3. Why did I say 27? Who goes into 27? But 4 squared is 16, 5 is 25, 6 is 6, 36. Ignore my 27 there. Ignore my 27 there. Yeah, I got me thinking about math. So by doing the division, n equals d squared, 1 of d or d2 has to be less than. Suppose both d and d2 are not square root of n. You're right. That would definitely lead to a better optimized time solution, definitely for it. Well, it doesn't matter about the space. I just want wait before I say that. Before I finish my sentence, I'm just trying to think like, will there be additional data structures to hold that for me? Because I wouldn't really care. Because all I would do is that if I do see that, all I would do is just increment count, and at the end of the day, we're just returning count, which is just going to hold that single integer, which is going to be all 1. Yeah, so there wouldn't be any additional data structure. Yes, okay. I like that. Check if each num percentage total is equal to 0. Check if, okay, sorry, we're gonna check to see if it's clean, because yeah, I like that way of thinking about it too. So we're gonna check if each num total is equal to 0. If each num total, then we're gonna increment the count. Otherwise, we're gonna increment the count. Otherwise, we would let it keep. Otherwise, it will keep incrementing due to the for loop. But at the end of the day, we're just gonna return the count. So count is equal to 0. We're gonna say that for num in range starting at. We're gonna start at 1. Technically, 0 isn't a number that you can really divide by. Feel free to correct me if I'm wrong, but I'm pretty sure that any numbers for 0, my only thing is I can't really omit 0, can I? Because unless there is a case, so technically that would be like an edge case to take care of. You should only return a number, because if you are 0, I would still, if n is equal to 0, then I would say return 0, because okay, I think I'm overcomplicating this because the power of 0, but I think I'm overcomplicating this. But if you are 0 and you're going to divide by something, I think you can't divide by yourself. So I'm going to say it's going to be a 0. I'm going to say it's a 0. Feel free to correct me if I'm wrong. So we're going to see what the test cases state, but that's what I'm going to say. We're going to go up to the range. Okay, so this one, I'm gonna say the IDX and num in enumerate, because when you use a range function, all you're getting is just the index. So you're not getting the index in the value that you're looking for. So we're gonna look for the index in the value. We're gonna start at 1. We want to go all the way up to n, because we want to include that number. And then now we're gonna say that if n mod num is equal to 0, then we're going to say count plus equal 1. My JavaScript coming through there. Then we're going to return count. Oh, sorry, that's right. I'm not trying to assign. I'm trying to say that we're going to check if you are equal. Int object is not iterable. Okay, that is my fault. Okay, so then... Oh, it's plus infinity? Okay, so then my edge case here wouldn't work. That is my fault then. For num in range... Okay, in range of 1 to n plus 1. But like you said, we can definitely do it. Let me finish my space. Space is O of 1, because at the end of the day, all we're returning back is just a count number. So we're not storing any additional data structure like an array, map, or dictionary. A dictionary or anything. I want to make sure I use the right. Languages. Try not to get my JavaScript and my Python together. So, but yes, you're saying O of square root. Will make it run better. Okay, so let me just go back. I want to comment this out. Okay, so yes. Let me add my charger. Let me be right back. you're right. Okay, yeah, cause yeah, I didn't do so hot with math when I was younger, but we are doing our best and learning every day. So yeah. Okay, let's see here. So I'm looking at the notes that you wrote. I want to make sure. So d times d2, one of d has to be less than or equal to the square root. Because I'm thinking, okay, so let's work with, let me work with an example 4. Let me work with, okay, so let me work with the example 4. If you do 4 in the square root of, I wish I could draw you the square root, but square root of 4 is equal to 2. But wouldn't O of n log n, wouldn't that make that worse time complexity than O of n? Yeah, because when I look at a big O notation, isn't log of n, well, this is O of n log n. Wouldn't that be worse? Because I think O of n log n. Oh, it's actually better. So much stuff. Okay. Okay, so yeah, see, wouldn't O of n log n actually be worse than O of n? Therefore, my code that I wrote was better in the time complexity because it's O of n than O of n log n, because O of n log n isn't that good then. I wonder where O square root would come in. Because yeah, I can see why that's the case now, because yes. So when you're talking about square root, I'm trying to think about like square, okay, so that's the case. So I can picture 2, 12. So our example is 12. And I'm thinking about the square root of 12, which there isn't any. It's either 9, which is a perfect square root, or 16 is a perfect square root. So you have 9 and 16. So we're not obvious. I don't think we should go to 16 because that's way past our number. So let's stick to our 9. I am going to look at our 9. So our 9, you count the small ones, you can get the other ones by, so everything less than that. So yeah, it's because if I'm gonna get 12, the closest square root is 9, and that is 3. So then anything after 3 counts. But then how do you go up? So anything before the perfect square root, how do you go up to 4, 6, and 12? I wonder. But if it's okay with you, I am going to do this for the time being. But I am going to play around with your square root idea. Get commit -m, add it in divisors. Does anyone else add to their GitHub? I add to my GitHub too, just to, I added it to my GitHub because I like seeing a history of myself doing it. And along the way, like I've come so far with algorithms. It's crazy, but I like to do it because I like to remember if I ever did it and stuff. So, this one's not bad because you can just return the length using a list comprehension. So, hey, they did. It's similar to what I did, but they just turned it into list comprehension and they made it return the length of it. So, um, basically, every element for element in the range of 1 up to that number, and you're gonna say that you're gonna check to see if it has a clean remainder. And that's what it is. I wonder if there's like a divisor 2. I wonder, yeah, so I wonder if there was like any square root, if anybody thought about your square root. X range. I've never heard of the X range. Oh, isn't this what kind of doing what your the square root? And then you're okay, cause yeah, integer of n up to 0.5 power. I think that's taking a square root. If you do it like this, I think it's taking a square root. I see. I'm gonna leave this page as is. I want to come back and try to reread. Yeah, I don't. Yeah. Oops. 6. Okay, this one has been chosen. Alright, so we're gonna take a 10-minute walk today. So we live in the city. We're all. Ooh. I think I remember this one. Okay, so we live in a city of Cartesia where all roads are laid out in a perfect grid. Okay, so then you arrived 10 minutes early to an appointment, so you decided to take opportunity to go for a short walk. The city provides the citizens with a walk generating app on their phones. So every time you press a button, it sends you an array of one letter representing directions to walk. You should always walk a single block for each letter. You know it takes you 1 minute to traverse one city block. So create a function and return true if you will take you exact. You don't want to be early or late, and will you return false otherwise? Okay, let's talk about our inputs, and we'll play with the example to try to see where we're getting to. Okay, so we're gonna receive a list of lowercase letters representing directions. And then we need to return Boolean to see if we can walk. See if we can walk in the meantime. So if I have, so you always receive a valid array containing a random assortment of direction letters. It will never give you an empty array that's not a walk, that's standing still. Okay, so I am gonna go ahead and take their first example. I want to understand why this wants to return true. First and foremost, like one thing, a couple notes that I want to take into consideration here when I was reading this is that you always walk only a single block for each letter, and you know it takes you 1 minute to walk one city block. So one letter equals 1 minute. So that means I always anticipate so I always anticipate this length will be less than or equal to 10 minutes. So if this is greater, which one is the perfect one? Should return false, does not bring you back to the start. False. Okay. Well, my thing is that if it's greater than 10, that means we're walking too far. That's the way I get at it too. So let me just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we have an amount of 10. So we know for sure that if you are less than or equal to 10, we'll make it back. well, we're generally going to lean more towards the true. But because if you pay attention to all of these other examples, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All of them are greater than 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I lied. Okay, length doesn't matter. Okay, that debunked my thought of that. Okay, let's play with something else then. It should return false, should return true. And the reason why this returns true. Okay, so it seems that you're going down. Okay, so you go up north, you come back down south. You go up north, you go back down, go up north, go back down, go up north, go back down, north, south. So you return back to your original position. So this one, you're gonna return back to your original position. And I want to play. Okay, so essentially, okay, my head is trying to think right now. Feel free to let me know what your thoughts are too, as well. Is that we can walk away as long as we all come back to that same position. So if we can walk in the meantime and return back to original position. But my question to you is how do you know you are moving away from the position? This one, okay, so the way I'm thinking about it, I'm gonna keep count of blocks. So the way I'm gonna think about it is, okay, so we're gonna keep count of blocks and we're gonna initialize it to 0. Once we start moving away, we add to count. But if we come back, we minus from count. But also one thing my brain is starting to churn a little bit here. So north, south, north and south. You go north and you go south. That the directions matter as well. And now you're also going to go left, right, and that counts as well. And those will take, what's the right word I'm looking for? Take away from each other. They offset each other. Okay. So we're gonna say okay, so I'm gonna say something like, okay, so if we go north, add 1. If we come back down south, minus 1. If we go east, add 1. If we go west, minus 1. I'm just trying to think, like, is that the right way to think about it? Let me just use, because yes, this one makes sense, because you go north, south, cancels out, so 0. North, south still cancels out, 0. North, south still cancels out. So ultimately, this is equal to 0, so we get back to our original position. So let me play with this other one. Example. Okay, so we have our count right now of this. So we have our count. So let me just go back a little bit. Okay, so we went west. So this is 1. Okay, so we went 1, and now we're going east, which is back to minus 1. So our total right now is still 0. But now we went back to west. So we add 1. So we go back here, we're at 1 again. But now we're going to east, and then we're negative 1, and then now we're going back to 0. But now we went back to 1. But now we go back to 1. W-E, 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 W-E. I still think return true will give you exactly 10 minutes. You don't want to be early or late. I think the length still plays a role into it because this one should ultimately, as you can see, they all offset each other. I still think that this one should be equal to, I think, so this one would still be equal to 0. They all offset each other. But the fact that it's greater than 10, I'm going to say it's false. But that, I was going to say if the length is greater, how about let's say, if the length is greater than 10, we're going to return false immediately. If the length of walk is greater than 10, we're just going to return false. I'm going to say that's for an edge case. We're going to find out if I'm right. I feel like that should be a situation to consider. Otherwise, what I'm going to do... Okay, so we know... Okay, so blocks is equal to 10. We know that our block, one block equals 1 minute, and we can only go up to 10 blocks because we need to do it in exactly 10 minutes. 10 blocks. We want to do it for 10 blocks. 10 blocks. And we have our count at 0. If I was going to say, do I add a direction? I was going to say, do I add a direction map? Let me brainstorm this. And let me visually kind of see it like laid out like this. And we're going to say you're going to be a 1. And then south, you're going to be a -1 because we're going back down so we can offset. East, let's go east. If I go east, we're going to say -1. I don't think there could be a wrong. I think, let me see. So we're going to say that for char and walk, if direction of walk, if walk in direction, if walk in direction. Hi Elder, long time no talk. Happy Friday. Oh my goodness, where are you going? Safe drive, by the way. If the walk does exist in the direction, we're gonna say blocks minus equal blocks minus equal. Do you want to say blocks minus equal or you want to say blocks plus equal? If the walk is in the direction, subtract from the blocks or add from the blocks. I totally know what you mean. Fort Worth. Get some... Fine. Oh my gosh, take a picture. Take a picture for me. I've heard great things about Buc-ee's. I felt like I seen it in Austin, but I can't remember it. It's really faint. Oh, okay, take a picture. Let me know. Have fun. Okay, so for the char and walk, if walk is in the direction, I'm going to say minus equal. I don't think it's right, but blocks minus equal the direction of the walk. So this one will grab the value and we're going to subtract it from the block. So we're going to say return blocks equals 0. Oh, how fun! Austin's always a great place. I hope you get to soak up in the, what is it called? Barton Springs? I love that. When we were there, we loved it. It's a little deeper. It's deep. In some areas, I didn't think it was going to be so deep. It's really deep. But, oh my goodness, have fun, Elder! How long will you be in Oklahoma for? If direction, walk, then if it does exist, subtract. Thank you so much, Elder. Have a great drive. Oh, you're right. Sorry. Direction char. I was like, the list? Where does this list key come from? Because I keep using walk, and I'm going to use char. Let's go ahead and see what my block is doing. Print blocks. Okay, so we're going 9, 10, 9, 10, 9, 10. Ah, okay. Let me think about this. Because the reason why I say return blocks equal 0 is because this will return a truly or a falsy already. So I don't need to declare it and state if true equals this or else false do this. Because I don't think that's what I'm looking for either. Let me just sit and think. Because I almost... Okay, so for sure now we can delete count. Because we're not using count. But... although it may work here, I'm going to try to attempt. Okay. Return false. Okay, what does it say? Should return true. It should also work for SE. Okay, we're on south, east, west. These two cancel each other out. This one should cancel this. Cancel this. Yeah, let me print out blocks to see. Okay. You didn't like it, huh? East-west cancels out. East-west, it cancels out. West, north-south. North-south. Cancel, cancel. South-west-west. I don't think it should. Okay. Return blocks equal 10, else. Return if blocks is equal to 10. Return true if blocks is equal to 10, else. True should equal false. Return false. False if blocks does not equal to 10. Else. True. Return false if blacks does not equal. After the if expression. So you're going to say return false if the black does not equal. That's my fault. take a 10-minute walk. Okay, so let me think about this. Let's go ahead and use this example. Okay, maybe this example. En. So in my example, I'm saying En, they cancel each other out. E and N. So I'm going to start the blocks at 10. Because who's to say this one is 1 and this one's -1? Who's to say that north and south is 1 and -1? Let me try to think if there's another way to do this. I am trying to think of how to keep count from the blocks. If they're direct, how do I say the opposite of each other? Because the reason why I was saying this is north and south are opposites. So, and east and west are opposite. So this is what I'm essentially trying to say, that if you go one way and you come back one way, we offset each other, we're still at 0. Because if I went east and I went back west, then that should offset each other and we're back at the starting position. But we can only go up to 10 blocks. Okay, so it's not even just a 10 blocks. It's not even, 10 blocks, but the current position, do I want to say the current position is at 0? Or do I want to say the current position is at 10? Because if we keep adding, something's jogging. Because I'm trying to say that the current position, I'm trying to say how are we back at our current position. So that's what I need to keep track of. I want to keep track of that current position. So I want to keep track of that current position. N and south are opposite. If N increase 1, if south -1. But how do I know that we're back at the current position? Could I say current position is equal to, that looks so funny. But could I say the current position is equal to 10? And could I add up I'm not just trying to say, hey, I walked 10 blocks. I want to say I walked to this current position. Walk back to this current position. 10 is how many blocks I can travel. And you can travel wherever. Current position, north, south, east, west. We're going to say for every walk, that wouldn't be the case though either. Current position plus equal every direction. Maybe we don't care. Blocks is how many blocks we travel. How do I keep track of the current position we started? Do we go, current position we started would be at 0. And if I walk north, that adds 1. If I walk south, that -1. If I walk east, add 1. If I walk west, I'm coming back west. Any hinters out there? I think I just need like a small little hint to push me going. just like a smaller hint. Like I have this idea of the current position. I need to see if my blocks, return blocks is equal to current. The amount of blocks I walk is equal to my current position that I started. But I never updated my current position. Because we're trying to get where did I do plus? What if I started at 0? I'm gonna say, hey, we both all cool. Okay, great. What if we both start at 0? We're both blocks that we travel at 0, and then we're gonna say that north and every other directions you repel each other, and then we're gonna keep adding up, and we're gonna see if I ended up back at the same position. No. Okay, let's figure this out. True should equal false. Blocks is 0. Any tips out there? I wonder. I just want to know, because I feel like, okay, so before I took Python, if walk is equal to the south and this is equal to south, and the length of walk is 10, walk.count is equal if the same walk count of each other. Okay. Oh, I was almost there. Yeah, let me just say. Okay, so if walk.count of W north is equal to, because we want to make sure the directions match each other, walk.count of south and walk.count of E is equal to walk.count of W, and length of walk is less than 10. Return true, else return false. Okay. If the walk.count of n, if this n and s is equal to the same amount, and if the or this should return false. I wonder why you return true. Oh, probably because you return true because the length of the walk is less than 10. Interesting. Didn't you say, oh, equal to 10 because we have to walk it within 10 minutes. Oh, it's all end. That is my fault there. I typically when I don't really when I haven't solved any problems, I won't finish them. I won't submit them because I do want to come back to it later. So I do feel like Man, I was like so close. Like my mind was definitely thinking of northeast and all these off north and east. Oh, where'd it go? You know what I was thinking about, and I was just taking a look at? I was taking a look at figuring out like games to help you play and learn React and state and props, components. So I didn't find any, but I found this website, but I don't know if this will do much. So you're gonna check out this welcome.md file. So you have to go ahead. So it seems like you have to go ahead. Let me read more about it before I start clicking anything and I download something that I'm not supposed to download. I don't want to download something that I'm not supposed to. But yeah, we'll definitely keep looking into it. I wanted to learn some React games. Maybe that's something I could definitely build later on. So soon to come on that. Okay, I saw a friend of mine talk about Flexbox Zombies, so let's go ahead and play it. I've never played it before, so I'm really excited. I wonder if my audio's on. Okay. Wait, don't look yet. Let me come back. Let me change my screen a little bit here. Let me change you to... Okay, we'll change you here for a little bit. Just hold on a second. Let me change. Has anyone ever played before? Okay, not too loud. I'm like scared of zombies. I don't like zombies. Okay. Okay, we're gonna go ahead and begin. Hold up. Okay, let's play this bad boy right here. Good, you're awake. Don't you hear the siren? Okay, listen up. The crossbow, that's where we get. Go ahead and start typing display. Hopefully not too scary. We're scared of these things. That's it. See how the flexible is able to release? That's because restriction. Video. Now we're gonna say flex. I love the learning and the hands-on that was so close. Okay. Yeah, he did look hungry. We need to let two partners for crossbows. Targeting system is just about easier. When the crossbow is powered on and aimed in the correct direction, it will protect zombie and you see that red laser in your crossbow? That's called a justified laser. So name it because you're justified say justified content. I see. Look at that. They're trying to space themselves out. Justified content, row, reverse. Oh my goodness, you guys, what is the last word I'm looking for? Justify content, right. What is the last word? Oh, flex N.
Tomorrow, let me check the weather. Let me check the weather for you. Let me tell it to you.
Okay, display column. space between. Flags end in space between. Space between, space around. Okay, so do we need these and then the setting is called align self. You don't set this one on the crossbow itself like all the others, but on the individual targets, it overrides the items. Alright, game time. This looks the same as the other game. I love this active recall. Justified flex say justified.